Self Dr. Adum Babu, Associate Professor of EC Department. In this lecture, I am going to tell the introduction of course Electromagnetic Theory and Transmission Lines. Electromagnetic Theory and Transmission Lines course mainly consisting of two parts, Electromagnetic Theory and Transmission Lines. The main course objectives of electromagnetic theory and transmission lines are: the first objective is about 3D vector calculus, coordinate systems, and electromagnetic field concepts. How coordinate systems are used in the electromagnetic theory, how we will find out the electric fields and magnetic fields by using any one of the coordinating systems, that is the cylindrical coordinate systems or rectangular coordinate systems or spherical coordinate systems. The second main objective is the selecting the proper appropriate Maxwell equations in electromagnetic theory for any applications. So in the electromagnetic theory, we will derive the four Maxwell equations, two Maxwell equations from electrostatics and two Maxwell equations for magnetostatics. These four Maxwell equations we will use in the analyzing the different quantities of the electromagnetic waves for different applications. Third course objective is propagation characteristics of electromagnetic waves at boundary conditions. How electromagnetic wave is traveling in different boundaries, that is a conducting boundary or free space or dielectric boundary. So what are the boundary conditions we will learn in this subject. Next, fourth objective is the ability to compute the various parameters of transmission lines by using the Smith chart. In the last part of transmission lines of this course, it consisting of two modules. So by using the transmission lines, we will use the Smith charts to calculate the parameters of the various transmission lines. Last objective of the electromagnetic theory and transmission line is to calculate the various parameters of the transmission lines using graphical methods. By using various methods, we will measure the parameters of the transmission lines like reflection coefficient, VSWR, or attenuation losses. We will find out by using the graphical methods also. Next, what are the course outcomes of this course? After learning this course, student will be able to learn which points or which methods a student will learn. So first course outcome is the understanding the characteristics of a electrostatics and magnetostatics for wave propagation. So by studying the electrostatic fields and magnetostatic fields, we can understand how electromagnetic wave is propagating in the different mediums, and this will be useful in the studying of antennas and wave propagation. Next outcome of this course is studying the Maxwell equations, how these Maxwell equations and applications, how these Maxwell equations are used in the applications of electromagnetic problems. By using these Maxwell equations, we will design some circuits to propagate the waves in a different mediums. The third course outcome is how electromagnetic waves are reflects and refracts in different mediums. So in this, by studying this course, how electromagnetic wave is reflected from a conducting boundary or reflecting from a dielectric boundary and refracted through the dielectric boundary, what are the reflection and refraction angles, different angles, how energy is flowing through different mediums, that will be learned by learning this course. Next, fourth outcome is analyzing the basic transmission line parameters at various conditions. So transmission lines having the two parameters, that is the primary parameters and secondary parameters. Primary parameters are resistance, conductance, inductance, and capacitance. Secondary parameters are transmission line secondary parameters are propagation constant and characteristic impedance. By learning these parameters at different conditions, means lossless conditions and lossy conditions and distortionless conditions. So how these parameters are vary with respect to the transmission lines. Next, last outcome by learning this subject is how electromagnetic wave propagating to the lossy dielectrics and lossy mediums. By propagating the electromagnetic wave in different mediums, what are the losses will be occurred, how the wave is propagating without any attenuation, that we will learn by learning this course. Next, coming to the modules or coming to the syllabus of the electromagnetic theory and transmission lines, it covers total 5 modules. The first module mainly covers with the electrostatics, that is the electrostatic fields. The charge here in this first module, charge is completely stationary. We will study the fields of the stationary charge only. First, it starts with the Coulomb's law. It is used to find out the force between the any two charges. By using the Coulomb's law, next we will find out the electric field intensity due to a point charge and different charge distributions. We are having the various charge distributions like line charge, surface charge, volume charge. So based upon the electric field intensity general formula, we will find out the electric field intensity of different continuous charge distributions. Next one is electric flux. Flux is nothing but lines of force. What is the electric flux due to any charge? Next, mainly we will discuss in the first module is Gauss law. Gauss law is related to the electrostatics. What is the Gauss law and how we will find out the charge over a closed surface by using the Gauss law. Next, what are the applications of the Gauss law that we will learn in the first module. Next, what are the scalar and scalar potential? Here charge is stationary, so potential must be scalar only. What are the different formulas for electrostatic energy density? Next, we will learn in the first module is what are the different types of materials, conductors and dielectrics. What are the properties of conductors and dielectrics? Next, what are the different types of currents? Current is nothing but flow of electrons, but generally we are having the convection current and conduction current. So what is the conduction current and what is the convection current? What is the difference between those two currents? What are the different types of dielectric constants? In the first module, we will learn the different types of dielectric, isotropic dielectrics and homogeneous dielectrics. Next, in the first module, mainly we will focus on the what is the continuity equation of the charges, how it will propagate in the mediums. Next, what are the different timings, relaxation times, and what are the different equations related to the static charge, Poisson's and Laplace equations. Next, in the first module, we will cover the capacitors, how capacitance will be calculated, what are the different types of capacitors, that is the parallel plate capacitor, coaxial capacitor and spherical capacitors. In the first module, mainly we will focus about the electrostatic fields only. In these electrostatic fields, we will derive the two Maxwell equations, that is related to the electrostatic fields only. Coming to the module 2, that is the magnetostatics. In the first module, completely discussed about the stationary charges. In the second module, we will the moving charges. Whenever the charge is moving, both electric field and magnetic field will be produced. In the second module, mainly we will discuss about the moving charge. So in the first topic of the second module is Biot-Savart's law. In the first module, what is the Coulomb's law related to the electrostatics? In the same way, Biot-Savart's law related to the magnetostatics. Next, Gauss law, whereas in the first module, in the same way, Ampere's circuit law related to the magnetostatic fields. Electric flux density, like here, magnetic flux density. So second module is completely we will learn about the magnetic statics, nothing but magnetic fields of a charge. Here magnetic field is consisting both the direction and magnitude. So that's why we will discuss the magnetic scalar and vector potentials. Next, what are the forces due to magnetic field? We are having the different forces due to magnetic fields that may be discussed in Ampere's force law. Mainly we will discuss the boundary conditions in the magnetostatic fields. What are the boundary conditions between the two mediums here, dielectric to dielectric, dielectric to conductor interface and dielectric to free space, conductor free space. For all these boundaries, what are the boundary conditions? We will learn in the second module. And in the first module, we will learn about the capacitors. Why? Because energy stored in the capacitor in the form of the electric field. In the inductor, the energy stored in the form of magnetic field. So what is the inductance? What is the basic formula of inductance? How are the different types of inductances? that is the self-inductance and mutual inductances. Next, magnetostatic energy, magnetic energy. Here also we will derive the two Maxwell equations from magnetostatic fields. That is the from Faraday's law we will derive one Maxwell equations. From the magnetic properties we will derive the another Maxwell equations. Next, here in the Ampere circuit law some inconsistency there. How it will be overcome for time varying fields, that is also we will discuss in the second module. Next, what are the final Maxwell equations? Four Maxwell equations in differential form and integral form. What is the one word statement of the Maxwell equations, that we will learn in the second module. Coming to the third module, this is completely about the wave propagation. How electromagnetic waves are propagating. What are the wave equations of electromagnetic wave? That is for free space or conducting medium or dielectric medium, good conductors, good dielectric mediums. What are the wave equations? After finding the wave equations, we will find out how wave is propagating in the different mediums. What is the refraction and reflection of the plane waves? So first we will find out the wave equations for conducting and different mediums. That is the conducting medium and perfect medium. Next, we will find out the relationship between electric field and magnetic field of a uniform plane wave. What are the relations? So is the two fields are perpendicular to each other, or two fields are in the same direction? What is the main relation between the E and H? What is the ratio of E to H? We will learn in the third module. And next, how waves are propagating in the lossless mediums and conducting mediums, that is the good conductors or good dielectrics. Next, what is the intrinsic impedance of a conducting surface or any surface? How we will find out the impedance? How wave is propagating in the good conductor? What is the skin depth of a good conductor? And what is the polarization? How wave is penetrating? What are the different types of polarizations? That is also learned in the third module. Coming to the reflection and refraction of the plane waves, we are having the two incidences. That is the normal incidence, that is nothing but 90 degrees incident angle, and next oblique incidence. Other than 90 degrees incidence is said to be oblique incidence. So how wave is propagating, how wave is refracted or reflected from conducting medium, that is with normal incidence and oblique incidence. Oblique incidence is nothing but wave is propagating to the another medium, that is the refraction. Two mediums, for dielectric medium and for conducting medium, how wave is reflected and refracted we will learn in the third module. And how standing waves are producing in the conducting medium or dielectric medium. What are the different angles, that is the Brewster angle, critical angle, and total internal reflection, surface impedance, we will learn in the third module. How energy is propagating from one place to another place. How electromagnetic wave energy is transferred from one point to another point, that is we will learn by learning the pointing theorem. And what are the applications of the pointing theorem? If the wave is transmitted through the good conductor, what is the power loss? What are the power losses occurring? What is the expression for the power loss for the electromagnetic wave traveling in a good conductor? That we will learn in the third module. So first three modules are electromagnetic theory, electrostatics and magnetostatics, and next uniform plane wave. These three modules are coming to the electromagnetic theory, and last two modules are transmission lines. So course is the electromagnetic theory and transmission line. First three module covers the electromagnetic theory, and last two modules covers the transmission lines. Coming to the fourth module, transmission line characteristics. We are having the different types of transmission lines: open wire lines, next coaxial cables, optical fibers, and waveguides. But whereas in this course, mainly we will learn about the open wire lines only. Open wire lines mainly used to transfer the electricity from one place to another place. To transfer the electricity, we are using those open wire lines are transmission lines characteristics we will learn by learning the fourth module and fifth module. So the first, what are the transmission line characteristics? That is nothing but open wire line characteristics. What is the different types of transmission lines? In the transmission lines, mainly we will discuss the open wire lines. In the open wire lines, what are the line parameters? That is the primary constants and secondary constants. Primary constants are R, L, G, C, and secondary constants are propagation constant and characteristic impedance. Propagation constant is P and Z0 is the characteristic impedance. These are the secondary constants. What are the expressions for primary constants and what are the expressions for secondary constants? That is the propagation constant, secondary constants. How energy is transferring those through transmission lines? What are the different velocities occurring in a transmission line? Phase velocity and group velocity. Next, infinite line concept. If the line is terminated with some impedance, if the line is not terminated with the impedances, so what are the concepts of this infinite line concepts and how the energy is propagating without loss? That is also discussed in the fourth module. What are the conditions to get the distortion less and minimum attenuation? The condition is nothing but R by L is equal to G by C. How this condition is used to get the distortion less line or attenuation, minimum attenuation, that we'll learn in the fourth module. How the transmission lines are loading, that is loading of lines means by applying the extra inductors to the transmission lines to get the lossless transmission or distortionless transmission. Different types of loading is there. Mainly we are using the lumped loading. All these transmission line parameters we will learn in the fourth module. Coming to the fifth module, this is the mainly we will learn the transmission line parameters at the receiver end. Fourth module is mainly focused on the transmission end. This is the receiving end. Here we will derive the transmission line equation at the receiving end. In the fourth module, we will derive the transmission line equation at the transmitting end. So what are the input impedance relations? That is the short circuit line and open circuit line. For short circuit line, what is the input impedance? And for open circuit line, what is the input impedance? How we will find out the reflection coefficient for standing waves? What is the reflection coefficient and what is the voltage standing wave ratio of a standing wave? How ultra high frequency lines acts as a circuit elements? So what are the ultra high frequency elements? How these are used in the transmission lines as a circuit elements, that is the inductor or capacitor? How these UHF elements are used for the circuit elements, that is the lambda by 4, lambda by 2, lambda by 8 lines. How these lines are connected in any transmission lines, that we will learn in the fifth module. How impedance is transformed by using these three lines for half wave line, quarter wave line, 8 wave line. How impedance is transformed? These lines are connected to the transmission line. How impedance is transformed? How input impedance is transformed to output? Both are same, or impedance may be increased or impedance may be decreased for these lines. How these lines will be attached to transmission lines, that we will learn by in the fourth module. Next, mainly what is the significance of a Smith chart? Why Smith chart is used and where you will use the Smith chart? By using the Smith chart, we will find out all these parameters of the transmission line, VSWR and reflection coefficient, and how the wave is admittance, and different parameters are there. We will find out the Z minimum and Z maximum impedance and minimum impedance. By using the Smith chart, we will find out all these parameters and what are the applications of the Smith chart, that we will learn in the fifth module. So fourth and fifth module mainly covers the transmission line characteristics. What are the transmission line parameters? How the characteristics are varying? How we will get the distortionless transmission by using this, and mainly focusing on the open wire lines. So complete 5 modules covers the course electromagnetic theory and transmission lines. Next, the standard textbooks for this course is, the first one is Electromagnetic Waves and Radiating Systems by Arthur Jordan and Bolliman. So in this textbook, you will find the modules of uniform plane waves and electrostatics and magnetostatics. Next, the second main textbook is Elements of Electromagnetics by Envo Sadiko. In this textbook also will prefer for learning all those modules. The reference textbooks are Engineering Electromagnetic by William Height and Engineering Electromagnetics by Nathan, and next electromagnetic field theory and transmission lines are situation. So this electromagnetic theory and transmission line EMTL is the starting basic course to understand the courses of antennas and wave propagation and microwave engineering and next radar systems. By learning this course, we will get some knowledge. That knowledge will be useful to understanding this course and understanding the various applications by using the antennas and various applications in the microwaves and various applications in the radars. So this is the basic course to understand the various advanced courses. So it covers the main modules of the electromagnetic and electrostatics and magnetostatics and transmission lines. Okay, these are the main course objectives and course outcomes of a course electromagnetic theory and transmission lines. Thank you.